Hi guys, we will talk about another method to estimate the demand or the number of customers. So we start with this picture, assuming that we have a lot of customer points in here, or a lot of residential buildings here, and each of them can contain a lot of customers. And then we have a shopping centers in different places like this. Okay, so the question is that last time we actually used the catchment method in order um, to match the customer to the centers. But do we have another way to do it, or are there other options? So actually, in this video, I will show you how to do it in the second method called the sub-link or the sub-assignment. So instead of assuming that one customer will shop in certain centers, we will assume that one customer can shop in all the centers. It just they don't want to they have different scores or different convenience scores to shop. For example, if the shop is near, then of course they will go there, but then the shop is a little bit far away, then they are willing to go with a lower score. And then if it's very far away, maybe they will do it once a year. So assuming that this kind of situation, how can we model it in our computational model in Alteryx? Okay, so I will show you how to do it. So the first thing is we need a joining or appending tool here to join all the customers to all the mm, shopping center. So it's the full join. So you have 10 customer, and if for shopping center it will be 40 relationships in total, or 40 pairs in total. Okay, so that's the first thing. In here, I renamed the the customer nicely already. But then if you want to, you can just still rename this to uh, for example, this one will be customer address. This one will be customer long, and then this one will be customer lat. This one will be cluster. We don't need anymore. Assuming that we customer point, so C point, and then this one, the distance I will get rid of. Mm, and then the actually I supposed to show you not the distance in here, so I will get rid of the distance, assuming that we don't have like a lot of data like that. It's too luxury if in the real world situation we don't have that kind of luxury. Okay, so the second one is the shopping center, so S center, and then catchment. Okay, so by renaming the columns, I actually show you the computational model, or like consciously show you the the rows of each column or each field in this case. Okay, so after I run this one, let me run this one. Then you will see the result like this. So you see the columns are nicely produced because of our naming convention. So you can see here, this is the address of the customer. This is the longitude, latitude. Actually, you can set, sorry, my nose uh, have problem again. So if you see, this is a, if you share this geolocation in the like a Google map or a Grab map, and then these number will appear. And then this is the location of the shopping center. Okay, so if you want to assign softly, so for example, like this customer here will shop in this Bedok shopping center, but with a small chance, or like small, they are not willing to come here, but they're more willing to come here or here. So how can you do that? Actually, we can do that with the uh, distance function. So I will use the distance here, and then I will use SD distance. So in this case, because um, the place is quite, Singapore is quite small, so you can use the distance between the 2 points to like uh, estimate in km. So so this is the distance, but if you want to convert this distance into the convenience score, then you invert the distance a little bit. So let us score from 1 to 100, and then you invert the distance in this formula, so you have the score in here. Actually, I don't need if you want levels, you don't need uh, decimal places. Then you just take the floor in front, mm, in order to make it integer, and then you can change this one to integer as well. So it will be a nice number or a nice level instead of like okay. So in here you can see maybe this one. What does it mean here? I read the row one by one for you. So this means that this customer here, you can see the highlight in here, uh, is willing to shop in this center with the distance about 3 km, 3.6 km, and then the score will be 21 out of 100. Okay. If you see the customer in here, for example, let me try to select the customer in here. So you can see the same customer has the different will have the different uh, score or different opinion on the shopping center. So you can see here, this one is 21 to CC Choa Chu Kang, and then this one, let me, I have to highlight all of them. Okay, so the same customer has the different opinion on the different shopping center. So he or she will more willing to shop in CCK, but less in Dover and less in Bedok and less in Bisan. Okay, so that's how the whole thing goes. In this case, the same customer. Oh, you can see here the highlight in all the places like that. Now we pick one more in here near the okay. We pick one in Bishan, and then we see how different it can be. Okay, this is our guy. Let me highlight four of them, and then you can see here this guy will think that Bishan Center is very convenient to the guy. So in this case, he or she score about 48 to Bishan, less for Bedok. So this is the Bedok. Less for Choa Chu Kang, which is this one, and then less for Dover as well. Dover is this one. Okay, so technically by score you can assign the customers to all the center, not like nearest center, but all the centers. Okay, so that's the first thing, and then the second thing is, can we group them all together in circles or in order to display? Because this one is like very crowded already. I want to make it more uh, organized in order for the audience to look at. So we can do that with the grouping method, and then in this case we just group all the points by the CVS, the convenience score, and then we see how. Okay, let us start with the first move to just CVS, and then we will see how it goes to move on. Okay, so in this case I just combine all the points together, and I name it a layer. So all the point of the same level will be combined in the same layer, and then it look like this. So you can see here, in the same layers. They are in the same layer, so you can just put them all together like this. You can click and then see. Let me only select certain layers. So I don't want to show everything. I only want to show like 10, 20, 30, and then how it looks like. So I will use the filter here, and then I will uh, mode of the CVS with 10 equal to 0. So it will show 10, 20, 30, and then let us see how it goes. Okay, so you see here, this is because, so you see some circles, but you see some in between as well mm, because of those guys actually come from all the places in different centers. So it is a little bit distracting. So if I want to focus on center by center, I need more grouping. So I need to group this one by the center as well. So let us group by center and see how this thing goes. Okay, so this one you see here. Let me uh, order this one by circle, by center first, and then by the level, and then we can explain the. Okay, so in Bishan we have this is levels 10, 10 level 10 from Bishan. So those guys are around Bishan. These are the for CCKs. We don't have this hub because there's no population in this area. No customer, not population in the sense that the other part mm, of Singapore, we also have the population in here, but then in this data set we don't have. Okay, so same thing with the Dover. So there's population here in Dover as well. Okay, so now you know how to read those numbers. So what if I want some uh, boundary from those points? So I can just group those points with the convex hull. Uh, I name it hull, and then I see how this thing display. Okay, so this one is a little bit confusing because uh, because this is how they form the boundary. Let us see if we can get rid of the 10 or 20, and then is it like a better picture? So I will read CSV, solid CVS bigger than 10, and then we see if we have a cleaner picture from here. So actually we do have the cleaner picture from each center. Just get rid of uh, the small numbers, and then sorry, and then in here we can just sort it by center first. Let me see by center how it makes sense. Center first and number. Okay, so and see how it makes sense in this case. Okay, so you see bedok, we have this one, and then smaller. When the score is the score in the center will be more, score will be bigger because it just means if you live in here, you will you are more willing to shop inside the circle near your house. Okay, so it's bigger, and then this one will also go bigger until the middle. Okay, so that's how it works in this case, and I just draw the convex hull here in order to sorry, in order to show you both. But then if you want to get rid of the point just to see the circle, then you just uncheck the layers here, and then we can display another layer. Okay, so it will be cleaner in this way. So you can go, let me see. So Dover is like this in the first circle is 20 and then 30 and then 40 and then so on. Okay. Um, so this kind of thing is the truncation model compared to this. So this is the overall model. So it's the full everything is in the model, but then it will be very messy or like a lot of things going on in order for you to read. But this one is a truncated model in the sense that we get rid of some noise or some small numbers, and then we have a cleaner picture, and then it will be easier for you to read. Okay, so if you want numbers, you can mix the count in here as well, or the sum in here as well. So for example, if I want to count the number of customer point, uh, I will CC here, which is customer count, and then you can see the numbers in different segment as well. So what does it tell us in here? It tells us uh, in Bedok. Okay, so here in Bishan. In Bishan, there are 60 customer point, not customer point. You have to multiply with the population in each point, and you have the customers. Within 20, within 20, and then within 30, level 30, then we have only 30 customer, and then 40 will be 11, and then 11, 50. So when you go far away, you have more customer, but then the your level of comfort or level of convenience will be smaller as well. Okay, so that's how uh, you perform the full assignment or full matching between the centers, the shopping centers and the customers. Uh, in the next video, I will show you how to turn this map into uh, the hard assignment, or meaning that you will assign each customer to the nearest shopping center.